In today's lesson, we're going to learn about solving log equations. So if you have a logarithmic equation, basically any logarithmic equation, and what I mean by that is an equation that has log present in it, any equation like that can turn into one of two things. Either you can turn it into something that looks like a log equals a log, right, something like that, or the log is just on the one side. Okay, and so understand in the first case, in scenario number one, the bases do have to be the same for what I'm about to say to apply. I don't anticipate you guys seeing a question in this class where the bases are not the same, so don't really worry about that. But that would require some other math, just want to be clear. And the second case, you just will have logs on the one side, but not on the other, okay? So let's look at a couple examples of each of these, and then there's going to be some problems for you to try just to test out your knowledge, okay? I did have a note here to remind myself to talk to you about extraneous solutions. Remember that you would have to have log of a positive number in order for the log function to make sense. So if your solution includes something where you're letting that not happen, like you have log of a negative, that's what's called an extraneous solution, which means it's not a solution that checks, and you would throw that out. Okay, so just bear that in mind. If you get something that makes you have a situation where you have log of a negative, that can't happen. Okay, all right, so let's take a look at these. So scenario number one was the one where you had a log on both sides. Now let's remember that this symbol in mathematics actually carries meaning. Equal is very powerful, right? Saying that these two things have to be equivalent. Well, this side already has a base 14 log, as does this side. And there's nothing else, right? Both of these sides of the equation say base 14 log of a thing. And then it is equal to base 14 log of a different thing. Well, those two things, although looking different, must be equivalent, because otherwise, how could we have that equal sign right there? So I would call this the justice in the universe property. If there is justice in the universe, which, oh, we do believe there is, this and this being the same implies that this part and this part have to be the same. All right, now this turns into an old question for us. This is just a quadratic equation, and we're going to solve it. So we take a look at this and we wonder, does it factor? And I do believe it does. Think about your signs to make that middle term be -2. So my solutions would be 9 and -7. Now I'm going to do a quick mental check about this extraneous solution business. If I substitute in -7 into this side, I'm going to have log of a negative. Right, I'd have -14 minus 1, which is -15. So this is what we would call an extraneous solution. The extraneous solution just as easily might have been the positive answer, right? Just if it leads to something negative. Oh, wait a second. Actually, what happens with the 9 on the other side? Oh, no, we're okay. For a second, I thought that might be extraneous on the other side. Okay, so 9 times 9 is 81. So that's okay. That part's okay. All right. But you have to just double check and make sure you don't have a log of a negative. All right, now the next box says it's the same scenario eventually, because although it doesn't look like either case at the beginning, if I use a log property, I can make the left side a little bit more compact. So this is the place where log properties are going to be useful. So I'm going to take the base 7 log, and then since I'm adding, I could multiply. 5 times 5x squared is 25x squared. And then this side I'm not doing a thing with, just carrying it down. And now I can use my justice in the universe property, right? Equal means equal. So if these already match, then the rest of the equation has to match. So I'm going to divide on both sides by 25. Take the square root of both sides. Remember my plus minus. Then I'm going to check for any extraneous solutions. And I think we're in luck here with both of these answers, both positive and negative 2/5, because here when I square it, that'll make everything positive. So I'm okay. I don't have a log of a negative. I only have logs of positive amounts. Okay, the next two boxes are the other scenario. The other scenario was when you just end up with logs on one side of the equation, but not the other. And you might need to do a little bit of adapting at the beginning, but that's okay, right? You just have to turn it into one of the two cases. So here, if I subtract that 9, just like normal Algebra 1 kind of math, and then divide by 5, I have the base 9 log of x plus 1 as a quantity. Divide the 5 over and I get -1. So the strategy when you have logs on one side is to not have logs at all. Make this into exponential form. So 9 to the -1 equals x plus 1. Remember, our negative exponent just is a switch of upstairs and downstairs, numerator and denominator. And so then I can just subtract that 1, and I get that x is -8/9. Now let's see if that's going to be problematic. I have right here, whoops, if I have right here, oh my goodness, I must be bumping something. So if I plug that in right in here, do I still have a positive that I'm taking the log of? I do, so I'm okay. So this is not extraneous. So we're all set. Okay. On this next one, we are going to again use a log property to help us turn it into one of our scenarios. So since I have a log with subtraction, I know that I can rewrite that with division. Since I only have a log on one side, once I have it just down to that single log, then I can switch it to exponential form. And 9 squared is 81, which I will write as 81 over 1. And this is just a little cross multiplication problem, a little rational functions thing. So then I would get, subtract an x, and I'd have 80x equals -1. So x is -1 over 80. So now I want to make sure I don't have anything extraneous. Oh, but I totally do, right? I have a log of a negative and a log of a negative. So this is going to have no solution, no solution. Okay, there are 6 more questions for you to try. The answers are posted on Schoology. Your teacher might also choose to go through these problems in class, but that at least gives you a start. Thanks.